Hey guys, we are going over the 2.5 notes today. This is the learning target that you guys can write down. You can pause the video if you don't have time to write it down. We're going to hop in to this first proof right here. Okay, so we started these last time on 2.4, and you will again need to look at these reason codes that we talked about last time, that we've really been talking about the last two class periods. And we filled this out. And we're going to make one tiny change to this one at the bottom, but I'll wait till we get there to discuss it. This first one right here, so remember we have what is given, and ABC and CBD form a right angle, that is something that is given. So since we know that that is given, we just write that given in the reasons. Then it talks here about how ABC and CBD are complementary. I'm just going to give you this reason. This isn't actually something that you will see again. We did not put it on your proof's reasons code, so I don't want you to worry about it, but it is just the Complement Theorem, which basically just, you look at the picture, these add up to 90, that's what the complement theorem is. But that's not something that you will have to come up with again. So we're just going to put it in here in the notes. But we are going to use it for the rest of this proof. Alright, so it shows that they are complementary. And then the next one, it says the measure angle ABC and CBD, they add up to 90 degrees. Okay, so if they add up to 90, we're going to look back over here at our sheet, and the word complementary is right above it. Okay, so we want to, kind of think, all right, we've got two angles that add to 90. It's going to have something to do with complementary. So we want to look at our reason codes, and the definition of complementary angles is this, that, you add two angles together and they equal 90. So let's see what we have going on this proof. All right, yeah, we have these two angles added together and they equal 90, so that's just going to be that definition of complementary. Okay, so that one is definition of complementary. And then I want you to notice what's going from here to here. So somehow we've got to figure out how this angle goes from angle ABC to its actual value of 5x, and then CBD goes to 4x. If we look up here in the given, that is given to us. All right. So remember, we've got this transitive and substitution property that are easily mixed up. This one, in this case, you are just substituting 5x for ABC and substituting 4x for CBD. So it's just substitution property. So it can't be transitive because there's not two things that equal the same thing, therefore they equal each other here. It's just we're substituting 5x, we're substituting 4x, and then we move on. Alright, and then from here to here, the only thing that's happening is we're adding two things that are on the same side of the equation. So we are just combining like terms. Which is also called simplify in here. Simplify and combine like terms. And then from here to here, you're like, okay, what are we doing? We are dividing by 9 on both sides, so x is going to be 10. So it's just division property of equality, or division POE. That's what I usually write. Because it's the property of equality because you're doing it on both sides of the equation. Alright, and then we have solved it. We have gone from the given all the way to x equals 10, and we've given reasons for how we've gotten there. Up next is this problem. Okay, so we ultimately want to go from this angle BAD, and it shows that it equals EAC, but we want to figure out how BAC and EAD can equal each other. So that's the process that we're going. So if you notice from this step to this step, the letters don't change at all. Alright, The only thing that changes is it goes from a congruent symbol to an equal sign. Alright, so anytime it goes congruent to equal, it's just going to be definition of congruent. Don't overthink that. Always check. Anytime something is the same from one step to another, check and see if the change is the congruent symbol. And that's a big help on figuring that out. Okay, and the next step, last time we talked a little bit about if there's a random addition symbol, random plus sign that comes out of nowhere. Like, where did that even happen? You need to look at the picture and see if it could possibly be part plus part equals whole. Because if it's part plus part equals whole, then it's going to be, the segment or angle addition postulate. In this case, it would be angle addition postulate. So let's just check. So BAD, and then are the two parts listed, BAC and CAD. Okay, yes. This first one, check. It's angle addition. And then we've got EAC, which is the whole, should be the whole thing. And then EAD and CAD. Check. It's part plus part equals whole. So we're going to call it angle addition postulate. Anytime an addition symbol comes out of nowhere. Alright, and then BAC plus CAD is equal to EAD plus CAD. So that's a lot going on there. But what you need to do is look at the previous steps and see where those came from. And if we look, it's this half of the equation and this half of the equation. And what we've done is we've taken those equations and put them equal to each other. Alright, now we got to figure out, is this going to be transitive or is this going to be substitution? So remember, the only way it could be transitive is if it's something that looks like this, where two things equal the same thing, therefore they equal each other. Alright, so that's the only way it could be. Substitution would be if we are substituting pieces of equations out to set things equal. But in this case, we set these two equal to each other, but BAD and EAC are not actually, they're not the exact same thing. Okay, so to be able to set them equal to each other, it can't be transitive property. It has to be substitution. Because it does not, these two are not the same. So it can't be transitive. Alright, so this step right here cannot be transitive. It has to be substitution because it's not the same. These two angles are not the exact same. Alright, moving right along. Alright, this is kind of it's a weird look right here because it's actually this is equal to this. So we've got to figure out how we go from here to here. So somehow we've got BAC and EAD down here, but the CADs disappear. So what happened was we took and we subtracted CAD from both sides. So anytime we subtract something from both sides, be the subtraction property of equality when you subtract something from both sides, even if it's not numbers. Okay, then from here to here, nothing changes except it goes from equal to a congruent symbol. So same thing as what happened up here, is just backwards, but it's going to be the same reason. Definition of congruent. And yes, it is perfectly fine to have the exact same step multiple times within your proof. It's not an issue at all. Alright, let's move on to the last one. We're going to work this one out together. But as we work it, we're also going to fill in the statement side. So go ahead and write BC bisects angle ABD, because that is given. And then on the bottom one, we've got to write what we're trying to prove. The measure of angle CBD is equal to the measure of angle FBE. This you do not write the word prove. You're going to want to, but don't do it. The given is what's given. This is what we're trying to prove. Okay, anytime there is a word in your given, you want to circle that word. Make sure you circle it and draw attention to it, because eventually we're probably going to define that word. The definition of bisex is probably going to be one of our reasons. So let's look over at our picture and let's draw what is written out. We've got BC, ray BC, bisects ABD. So we know that this and this are congruent. Alright, how do we know that? Because we know what the word bisects means. So we've got to figure out, alright, what did I just do? I just figured out that ABC and CBD are congruent to each other, because that's what the word bisects means. So we need to write that down. So ABC is congruent to angle CBD. And we know that because that's the definition of bisects. Cool. Alright, and then if you look at the definition of bisects here, it means cuts in half. You're going to have two congruent segments or two congruent angles. So it will just show the two congruent angles or segments. Alright, so definition of bisects. And then we are trying to ultimately prove that CBD and FBE are equal to each other. So we have to figure out some way to get FBE into the loop. Well, one thing that we know is that these two lines, they create vertical angles. So angle ABC and angle FBE, they're vertical angles, and we know that because we know what vertical angles are. Alright, so this would just be, you can just write vertical angles here. And then this is one thing that I want you to add here. So typically when we are working these problems, you will just be filling in the reason side. Okay, so I want you to go ahead and add this next to the bottom where it says definition of vertical angles. Add vertical angles theorem here, because if it's a quiz or a test or on your assignment, if you just write vertical angles, definition of vertical angles, it's going to count as both. Vertical angles show that they're both congruent, but they also show in the picture that they just are vertical angles. So we're writing it out in two separate steps, but for the most part, really you just need to know that vertical angles are created, they're opposite from each other, and also that they are congruent to each other. So since we know that they are vertical angles, we can say that they're congruent to each other. So we can also mark that. So this is technically the vertical, this is technically the definition. Then this is the theorem. But you won't ever have to know them as separate, okay? If the answer is anything about vertical angles, there will be only one answer to select. Okay, so I don't want you to overthink that. This is basically just the same answer 2 times in a row. Okay. Oh, I should have written R vertical. Okay. Now, if you look from here and here, our end goal is to figure out that CBD is equal to FBE. Well, if you look at step 2 and step 4, you will realize that both of these angles that we're looking for are equal to the same thing. So this is where that transitive property comes in, of two things that are equal to the same thing. So angle CBD is equal to ABC. Angle FBE is equal to ABC. So we're still using congruent symbols here. I'm using congruent all the way through. And they are congruent to each other because they are the same as ABC. So two things equal to each other or two things equal to the same thing are going to be equal to each other. Transitive property. So it seems like it would be substitution, but since this entire side of the equation is the same, and then you set these two equal to each other, it's actually called that transitive property. Okay? And then the last one, there's no change from CBD to CBD, and then same thing from here to here. The only thing that's changing is it goes from congruent to equal. So that is going to be the definition of congruent. And it perfectly matches what we are trying to prove. All right, thanks.